Hello, welcome to Computer Tech and More. Today we're going to be taking a look at the Kaze Flex 2 120mm Slim Fan by Scythe. Let's get right into the graphs. Before we get into the graphs, here is the product information that I found online on the manufacturer's website for the Kaze Flex 2 Slim Edition, and I have it compared directly against my only other slim fan I've tested so far, and that's the A12X15. Both are standard 120mm fans, except they are 15mm thick. The bearing type for the Flex is a fluid dynamic bearing, while the A12X25 is an SSO2. Both are 12 volt. Power consumption is 0.18 amps for the Flex 2 and 0.13 amps for the A12. RPM range is very similar. The Flex can go down to 300 and maxes out at 1800, while the A12X15 450 to 1850, so very similar overall. Airflow for the Flex 2 is 58 CFM, and for the A12 is 55 CFM. Static pressure is 1.36 for the Flex and 1.53 for the A12. Noise value, this is hard to test, compare against for manufacturers because you don't know how they tested it, but for each of their ratings individually, it's 27.8 and 23.9. Mean time between failure for the Flex is 120,000 hours, and for the A12 it's 150,000 hours. Alright, first up in the graphs we have the case simulation test. So in this test I have a simulated box that holds up to 180mm size fan, and there are a couple different ways of looking at this type of testing. The main purpose that I think for this is to look at how a fan shoots out air. So in an ideal world, the most perfect case fan would have a basically cylinder of air shooting out directly behind the fan blades. That ignores aerodynamic losses, that ignores air resistance that the fan has to push out of its way, and anything like that. But we don't live in that sort of ideal world. So what we do look for is for that airspeed drop to be as slight as possible and to be as linear as possible. That indicates the best possible performance. If you see a very steep drop off at the very beginning, it means that the fan is shooting air off to the sides and not really down along the case. And the other way to look at this is as a case simulation, so a computer case. So I took it at 4 data points: 6 inches, 9 inches, 11 inches, and 14.5 inches. And those are representative of different size cases. So 6 inches is like a small form factor case that still is able to have relatively free airflow. Or, for example, like the Fractal Design Torrent, I can put fans right in the bottom of the case and blows air directly at the GPU, some sort of application like that. While 9 inches represents a small form factor case that is still more or less a bog standard case format. So that's front to back airflow into similar to a tower cooler. 11 inches is representative of a mid-tower case, something like the Fractal Design Meshify 2C or the Corsair 550D, something like that, where it's more of a mid-tower. And the 14.5 inches is representative of a big case. Something like the Fractal Design Torrent would be very representative of that 14.5 inch mark. If you're looking at water cooling, you can probably skip this section because if you're going to be blowing the air directly through a radiator, these graphs won't be as applicable because radiators will have a tendency to strain out the flow unless you put it in a pull configuration with the fan behind the radiator blowing into the case. Then these would still be applicable. Next up is noise normalized distance from the fan versus airspeed. Still in that case simulation test, but now we've added in graphs for directly comparing the A12X15 to the Kaze Flex 2 Slim versus my control fan. My control fan is based off of 3 parts the A12X25 and 1 part the A12X, or not the A12, the A14. The A14 being a 140mm fan and the A12 of course being 120. And any fans that are over in this area should be considered a good fan. If they're close to the line, they should also be considered a good fan. So over it is actually very good. And if they're below it, they should be considered okay to way bad if they're too far off of it. So it's pretty clear how these fans rank against each other. The Kaze Flex in this red line is doing pretty good overall. It is below my control fan, but compared to my only other slim fan, the A12, it's doing markedly better, surprisingly. So if you have like a standard tower case, you probably don't really want to use these, although they kind of would do okay. But if you have that small form factor, you can note that you're not giving up too much. Taking a look at things at 100% PWM fan signaling, I ignored the A12 in this because we're specifically focused on the Kaze Flex. It's following the trend line very well compared to my control fan. So overall, I would consider that a fairly good result, considering that it's a much slimmer fan and you can't get as much, basically, geometry on the fan blades. Well, then the question is, how does this fan, or these fans, compare against other fans that I've tested? Well, I have both the A12X15 and the Kaze Flex 2 Slim on this graph, and the lighter blue line is the Kaze Flex, the darker blue line is the A12X15, and you can see that they are kind of in the middle of everybody else, so that's actually not a bad place to be. The P12 from Arctic is right here. There are other fans in the 120mm category, the standard size, that are doing substantially better at farther distances, but overall I would say that it's not a bad result considering, again, these are slim fans, and they are far from the worst. If we take a look at things at 100% PWM fan signaling, the fans are basically still right there in the middle. It's honestly not a bad result for these fans. We do see that they did change places, bouncing back to the previous one real quick, that the A12X15 is now superior to the Kaze Flex 2 Slim. Again, considering similar RPMs, although the A12 ends up being noisier. So on this graph, I forgot to mention, we have RPM and noise level, the model, RPM, noise level. So you can set your priorities where you want them to be, and considering the relatively similar performance, you may not want to give up that noise performance, because remember, every 10 decibels is a doubling in noise volume. So that's a pretty substantial difference in noise value between these two fans. But they're far cry away from the better fans, but of course they're spinning at higher RPMs and they're making more noise. So if we're looking down here, you can see where everything ranks. They're honestly doing pretty well, especially considering their noise value and the fact that they are slim fans. Taking a look at these fans at the 9-inch case airflow test versus decibels, so that's decibels, horizontal, airspeed, vertical. So better fans are going to be sitting over here in the top left. Worse fans are going to be sitting more towards the bottom right. And the 9-inch mark, I personally have kind of found, is where the fans that do shoot air off to every side tend to drop away but aren't completely abysmal, that it's really hard to get readings, while the fans that do have a good concentrated airflow are still doing really well. So it's a great middle ground between basically bigger cases and smaller cases. And if we take a closer look at the data, right here is the Kaze Flex. It's honestly doing pretty well. It is more or less in the middle, while the A12X15 is once again also in the middle, just having a little bit higher top end in terms of airspeed for the consequence of a little bit more noise. But for equivalent air speeds, the A12X15 appears to be a little bit noisier. I would like to note at this time that my standardized noise value is at 40 decibels, and that's based off of the A12X25 running at around 1,200 RPM in my old Corsair 550D case running through an AIO radiator, 2 fans blowing through it. I just found that particular RPM to be particularly silent on those fans. Speaking of radiators, next up we have my CPU cooler test. In this test, I ran the fans through my CPU AirCooler, which is the U12A. it has a fairly dense fin stack, so it's fairly representative of both air coolers and moderately dense radiators. I don't have a super dense radiator to do full blown pressure testing, but I think this gives us good indication levels for how a fan will perform at those kind of levels. So in these graphs, we got 2 for 1. We got RPM versus airspeed through the cooler, and on the right side, we have noise through versus airspeed through the cooler. Airspeed is vertical on both, horizontal is RPM on the left, and noise on the right. So if we take a closer look at the left side, this is a pure blade efficiency test. It's basically indicating how good is the blade geometry on this fan at pushing air through the radiator. If you watch like the Fan Showdown, this would be the kind of graph you would want to be paying close attention to. So here the A12X15 is the green line, the blue line is my control, and this orangish red is the Kaze Flex 2. So you can see that the Kaze Flex isn't as good blade designed. The blades are just not as efficient at moving air as the A12X15 or my control fan. Actually, kind of interestingly enough, at certain RPMs, the A12X15 appears to be better than my control fan through the radiator, although it is lacking at kind of the top end. If we take a look at the right graph, this one is how efficient the blade is at basically noise levels. And here, both fans are pretty poor compared to my control fan, except when we start reaching higher RPM levels. And the A12X15 is farther off the beaten path than the Kaze Flex 2 Slim. Now, opening things up to compare these fans against not all, but a bunch of other fans I think are representative of many fans available on the market right now. We have my noise normalized airspeed through a cooler, and I want to bring this up now. I originally tested noise normalized values, or actually all noise testing, with my microphone placed fairly close up against the fan blade because I'm filming in my office, a fairly noisy environment that's usually noise floor of around 30 decibels. So I had the thought, just place the microphone right next to the fan so that I'm only picking up the fan when it's spinning. Great in theory, but as I've done more and more testing, I've tested about 50 fans now, I started to get this inkling that I was picking up reverberation noises of the blades basically bypassing near the microphone, and I was getting extra sound in there. So while I was doing this test, I was also preparing essentially a whole overhaul in my noise testing. So I'll have a whole piece on how I've changed the noise testing, and I'll be redoing a lot of my original videos, as well as kind of having a summary video about where these fans will be placing now. But that doesn't change things for how I've tested it thus far. So let's really focus in on what we're seeing. I also wanted to note, because I'm going to forget otherwise, that my error in measurement is plus or minus 0.1 meters per second. This is the accuracy of my anemometer. Nothing I can do about the anemometer readings. It's just plus or minus 0.1. Noise readings are plus or minus 4 decibels. That is a pretty wide range. New testing is going to be closer to 2 because it takes a lot more time to do it. Anyway, some key notes about what we see on this graph. Over here, we see a number with the W and an equals to a number. That is a wattage equals an airspeed. So I did a whole piece with my CPU AirCooler, the U12A, where I tested it at a bunch of different RPMs with 2 fans. The original, or 2 fans, just one on it. The back fan is completely removed. The A12X25 and the Silent Wings 4 Pro. I ran the fans at pretty much a whole suite of RPMs and measured the airspeeds and determined what wattage the CPU would max out at, because I set the limit to only be temperature. So the CPU was always running at 91 degrees, and it was just whatever wattage the airspeed would allow it to achieve. So in all coolers, there's diminishing returns for more airspeed for how much wattage you gain. At some point, you'll be blowing so much air through the cooler that it's not really going to be picking up that much more heat. than something else, because you really need that radiator to be hot in order for it to dissipate heat. So also, my CPU is the 11700K, so if you have got the same CPU as me and the same cooler as me, you could probably more or less use this wattage data. However, every CPU is slightly different, so your results may be off by even as much as 5 to 10 watts. But let's say you got the same cooler and a different CPU. Well, then these wattages may not apply to your CPU. But what does apply is the rankings of this fans. Just like if you have a different air cooler than mine and you're looking to improve performance. But keep in mind, the amount of improvement you're going to see may not be as representative as what I'm indicating with my graphs, because of differences in density of the fins, or using a radiator, AIO, and that spacing. So there are too many variables to know how much difference in performance you're going to get, but you should notice an improvement in performance. So what I mean by is, let's say you're starting off on your cooler with an Arctic P12. Well, if you move up to the General Typhoon, which is also the Vento Pro, you're going to see a massive improvement in performance, meaning how much wattage your CPU can draw for a given noise value. Or if you think my noise value is too high for you, you can drop that down to a slower airspeed and get reduced levels of noise. That's how you can use it. So how does the Kaze Flex 2 and the A12X15 compare to other fans? Well, they're honestly kind of okay. They're not great. So the NFP12 Redux is actually doing better than them. The T30 is doing better than them. Pretty much a lot of fans are doing better, but the results aren't terrible overall. So I think that if you're in a small form factor, they would be perfectly reasonable choices. Again, same sort of thing as before, same talking points, except now we're taking a look at things at 100% PWM fan signaling, and the Kaze Flex 2 is way down here, and the A12X15 is up a little bit higher. So notice that they are close to within margin of error at that 0.1 meters per second. However, due to repeat testing, I can definitively basically say that there's a real difference in performance of basically that 0.1 meter per second, even though that is the accuracy of the anemometer, because I can test the fans over and over and over again and then average the results, and that's where it comes out to be. At maximum RPMs, they are well off the top contenders. So again, if you're looking at small form factor cases, space is at a premium. So if you've got to do what you got to do, know that they aren't the best. If you have room for a thicker standard 120 millimeter fan, you're pretty much guaranteed to get better results. But they're not bad. They're not bad. Taking a look at the data from a slightly different perspective, where it's air cooler speed versus a decibel rating, the Kaze Flex 2 is right here on the screen line. So that's pretty much no noise for no airspeed, and then it moves up. You're making more noise for very little improvement in airspeed, and then it kind of jumps up. As for the A12X15, it's sitting right here. So it's honestly kind of doing okay except for at the higher RPMs, it's not doing quite as well, but it's sort of doing better-ish. And the last of the main series of graphs is CFM testing. So CFM testing is basically a scientific test. I don't personally like it that much for trying to determine which case fan is the best, because you're basically putting a fan and blowing it down a tube with a measurement device at the end of it, an anemometer, and you're measuring the airspeed going down that tube. So by having the fan pressed up against, well, that, it is partially and mostly negating the fact that if a fan spews air out to the sides, it's still going down the tube. So a fan that shoots air off to the sides can hide the fact that it's shooting air off to the sides by essentially putting it up against the tube and blowing it down. Mind you will see differences. So a fan that does shoot off to the side will tend to perform slightly worse than one that has a more concentrated airflow, but it's gonna hide the results so much more. The one area where CFM testing is kind of applicable is if you're looking at radiators or as a heatsink fan, because the sheer fact of putting a fan up against essentially a grill or a grate or something like that, it will has a natural effect to straighten out the airflow. And as a matter of fact, in radiators, the fan, you want to have a nice pressure seal, and if the air is shooting off to the side, it'll still build up pressure kind of in front of those fins and then eventually just be pushed through anyways. Or in a pull configuration, completely doesn't matter. And so in those applications, that's where CFM kind of makes sense a little bit. So now that that explanation is out of the way, and that's why I also didn't include the A12X15 on this. How does it rank? Well, we can see the Kaze Flex now pretty much lines up perfectly against my control fan, and in noise testing, it's a little bit worse. Again, no real surprises. It makes a lot of perfect sense. But how does it compare against every other fan I've tested? Well, at 100% PWM fan signaling, the Kaze Flex 2 is actually ranked fairly well, right there. And the A12X15, I'm not sure why the NFF12 is highlighted, but the A12X15 is highlighted right there. They both have very similar CFM values. So overall, no real surprises there. Kind of a middle of the roads fan with the main pack series, which is impressive considering that they are slim fans. And sort of the last one we're taking a look at is CFM versus decibel rating. So right here is the Kaze Flex 2 in this brighter red line, while the A12X15 is this one. So you can see that there is a point of diminishing returns. They're very similar, very similar, very similar. Then they start to split. And the A15 kind of gets a little bit worse, while the Kaze Flex tends to get a little bit better. Now let's go to our open box experience, and then we're going to check out the value proposition for these fans. Okay, now that we finished taking a look at the graphs, let's do our open box experience. So this is the fan that, or the box, that the Kaze Flex 220 comes in. So if we open it up, it comes in this little plastic sleeve. It's got some mounting screws, some rubber grommet type screws for vibration reduction, and an extension cable, and that looks like about it. So let's take a closer look at the fan, and I'm going to actually be comparing it to the A12X15 because it's, well, another slim fan that I have, and I don't really have any other slim fans to compare against yet. So first off, overall in testing, the slim here was okay to good in case airflow testing, better than the A12X15 actually in my testing there. And in heatsink airflow, it was also okay to good. And this is on my Noctua U12A CPU cooler. But in this set of circumstances, it was not as good as the A12X15, but it didn't have a terrible score. As a note, slim fans are not generally as good in air pressure applications. They are there to fit into tight spaces where you essentially need a fan or you need that extra compatibility. So you can use it on a radiator, you can use it on a CPU cooler, but if you have space for a thicker full-size fan, you want to use that. So these fans would be specifically for small form factor computers. So one of the first and foremost main differences between these two fans is the Scythe has 9 blades and the Noctua has 7. The Scythe has smooth blades that are basically very rudimentary. There's, I would say, nothing special about the blades themselves. They have a little bit of a cup shape, a little bit of a hybrid fan blade design, but nothing compared to what we see on the X15, which have the flow guides, and actually the bottoms of it are they're pretty similar on the bottom. The main differences are on the top in that kind of featuring. The Noctua also has a bigger hub in the middle than the Scythe. In terms of frame features, the Scythe here does have removable pads, so they can be replaced with other colors in theory if Scythe sells other colors, but they're not compatible, and Noctuas are basically hard mounted to it. They are not removable by you. Both fans feature very square frames, which is good for sticking it onto a radiator and having it seal the air around it. So they could be used on like a 240 millimeter radiator and have two fans next to each other and push air through it. But again, that is not the fan specific use case. It's to get air where you need it to go and you have limited space. But they will, again, all things in consideration, they can work on a radiator if you are limited in space. Also, in terms of thickness, the Scythe is slightly thinner. So I had them sitting on the mat, and the Scythe is just a hair skinnier. And I think that it could just be because of the rubber pads on the Noctua, or maybe that they are fundamentally slightly different in thickness. If space is at the absolute most significant premium, the Scythe might be better. In terms of blade or fan longevity, I cannot test for how long the Scythe will last, but it is also less expensive. Let's see, other frame features. This one's frame is a lot more basic. The struts in the back appear to have less features on them, though not terribly unaerodynamic, but just less than what you're getting on the Noctua. So there's more engineering involved in this than what Scythe involved in, which is why they've got the different price point. There's also a pretty significant gap between the frame and the blades, so this probably uses a lower quality material, but the blades are fairly unremarkable, but it tested fairly well in testing, so it may overall be a good choice. Let's get into the value proposition so that we can talk specifically about that price. So first up, the Kaze Flex 2 is a $17 fan. The A12X15 is a $22 fan, so there's a pretty big price difference. $5, that's actually a fairly large percentage of the price for these fans. Now, how would you use this data? Well, if you're on an extraordinarily tight budget, as in money is everything, that's when you'd use this data 100%, because this is performance per dollar, which is what you care about the most. If you got a little bit of extra spending money and you're willing to give up a little bit on cost, so it's going to cost more to get better noise performance or something else, that's when you'd really be paying attention to this graph and comparing it against my earlier data graphs, because then you're going to be able to find the best ratio of what you're willing to spend for the best kind of fan is. And if you've got unlimited budget somehow, then I don't know why you're looking at these graphs, because you're going to just pick out whichever fans you want. But all of that said, how does the Kaze Flex 2 Slim compare? Well, honestly, in the value proposition, it's doing fairly well. It's not at the top, but it's doing pretty well. I do need to test more slim fans so that I can compare them against each other, but its results both at noise normalized and 100% PWM fan signaling aren't bad, especially when you compare it to other fans. I would call it middle of the road. At the 11-inch mark, it actually looks a little bit better than it did at the 6-inch mark. Mind, at 100%, it's dropped back a little bit, but it's overall still not bad. I put it in the okay category. Looking at it going through the CPU air cooler, here is a major weakness for it, I would say. It is well back from top contenders in the category, but if you only have room for a slim fan, it is a better value proposition than the A12X15. Both noise normalized and at the 100% PWM fan signaling, so know that it is an okay choice for slim coolers, but if you've got room for a thicker fan, you may be better served getting one of those. Last but not least, CFM testing. Here, especially at noise normalized values, it's done particularly well. However, looking at it at its 100% PWM fan signaling, it's more middle of the road in okay category. Well, this brings us to the end of the video. Conclusion for it, I think it's a just fine slim fan. Both it and the A12X15 have proven to be very good contenders, competing with and beating many standard 25 millimeter thick 120 millimeter fans. There are better cost performance ones, and of course there are better performing ones, but they hold their own fairly well. I really appreciate you watching this video and taking your time to check it out. If you have any comments on how I can improve the video, please leave it in the comment section down below. Check out my Patreon page. It's viewers like you that help make all this possible. I really want to upgrade my microphone, but it's just a little bit out of my budget right now. It's just me making videos right now, which is fine. I've always wanted to test out fans, and so this is labor of love for me. Well, that's my video comparing the Scythe to the Noctua A12X15. It's the only two slim fans I have right now, so I directly compared them against each other. For more fan videos, please subscribe to my channel or take a look at my other videos posted. If you would like to see me review a specific fan, please leave it in the comments down below and check out my Patreon page. Thank you very much for watching and have a great day. This is the raw data for the Kaze Flex 2 Slim. If you would like to use this data for your own purposes, you may go ahead and do so. However, if you do use it in a publication, I do ask that you reference me and my video because, well, I'm the one who generated the data, and it took an hour and a half just to generate this level of data, and much more time to film, edit, put together the presentation, writing script, all that kind of fun stuff. So it is a labor of love. It takes a lot of time. So I appreciate if you reference me. If you want to know the data for the A12X15, I have an earlier video where I go over that fan. Mind, it isn't as well formatted as this one, but the data is in that one and nothing has changed for it. Anyways, thank you for watching. Have a great day, and I'll see you next time here on Computer Tech and More.